All right, so this is Group 6, Senior Design, Electrical, and Computer Engineering, as well as Optics and Photonics Engineering. We have our Huddy Buddy device here. We've got the Arduino Mega 2560 here, which is the microcontroller and the hub of operations for most of our measurements. We've got the SIM 808 cellular GPS module for our emergency response recovery system. We've got our breadboard that contains the ADXL 335 plus minus 3G accelerometer. We've got the 5-volt converter there, which is attached to these batteries here. So these batteries produce 7.3 volts, and that steps it down to 5 volts to enable the SIM module to use the full 5 volts at a higher amperage needed to pull in the data from the GPS module. So how this works is we've got the OBD connector here. We plug the OBD into the vehicle, which provides power. At the current moment, the OBD provides power even when the car is off. So if the device is wished to be power off, we have the power switches here. So if we want to power on the device, we'll simply power on the main power. We'll power on the SIM power. And then the SIM power here has a little button on it to enable it. So then we enabled that and then reset the sketch. And then over here, we've got the OLED module. So that is going to boot up as the device is initialized. So we've got the start screen there. And then it's going to calibrate the GPS signal using the GPS antenna there. So once it's done calibrating the GPS, it will pull over to the OBD data. And right now we are just using the standard OLED due to the COVID-19 situation. Our optics and photonics engineer is currently in possession of the actual housing to reflect off of the display. So all we would need to do is attach both of those together to get the final product of the heads-up display being collimated. So as you can see there, we've got the display calibrated, or the GPS calibrated, and everything's ready to go. So on the left side, you've got miles per hour and miles per gallon. On the right side, you've got navigation. So the navigation will be updated via the app that Pedram will be demoing. So all we would have to do is transfer those character strings over to that side to put out the data. So right now I'm driving around just up and down here in my neighborhood, and you can see that the miles per hour and miles per gallon change off of the OBD data. So as I speed up, the miles per hour increases, as well as the miles per gallon. If I release my foot from the throttle, you can see the miles per gallon increases as the car becomes more efficient. And then if we slow down here and pull in to parking spot here, we can see that the OBD slows down. And so one of the benefits of our device that a lot of other devices don't have is the ability to send an emergency recovery response if there were to be an accident. We think the priority for ensuring that people are safe in the event of an accident is having the quickest response time available. So what we can do is, when the vehicle comes to rest, I'm going to demonstrate how we are able to send a response system. So what I'm going to do is I'm just going to pick up the display and then give it a little bit of a jostling to kind of mimic an accident. So on the OBD, we read the crash. On the emergency contacts phone, we will get a text message. Give it a second here. Oh, there it was. So we just got the text message saying that the crash was detected with the Google Maps link. So we click the Google Maps link, and that gives us a direct location for where the crash occurred. And you can see that it is very accurate to where we actually are located. So the big thing with our project now is due to the COVID-19 situation, we've kind of had to work from a remote location to get everything completed. It would be as simple as giving 2 or 3 days together as a full group to get the full heads-up display system collimated working. So that is our demo for the HuddyBuddy demo module.
Alright, this is Group 6. Our project is the HuddyBuddy, which is a heads-up display for vehicles. This is the enclosure for our actual display components, which would be the OLED, the 2 lenses, and a mirror. Unfortunately, one of the other group members has the OLED display, but I will still be able to demonstrate how the rest of it works. So we see here on this top piece we have a large 3-inch lens. This is a positive lens, kind of like a magnifying glass. If I remove this, we'll be able to see inside. We have a smaller 2-inch negative lens, which is similar to the lenses used in the glasses for people who are nearsighted. And we have a mirror angled at 45 degrees. With the OLED display located right here, the negative lens will produce a virtual image. This is a smaller image of the OLED display, and it looks like it'll be located right about here. If you look at it from the other side, it looks like it'll be located right about here. And this virtual image is what is seen by the larger positive lens. So the light from the display looks like a virtual image, goes through this lens, onto this mirror, reflects off the mirror, goes up into the positive lens, and is then collimated by the positive lens, or focused at infinity, which I will demonstrate. Please excuse the darkness, my phone screen isn't that bright. So here I have the phone with a image on it, and I'll be using this as the OLED display. I have here my enclosure configured so that I can fit my phone in there. And I'll be able to fit the phone exactly where the OLED would have been. I have a piece of plexiglass here, acting as the windshield. And here I have a letter A on the wall, which will be acting as an object in the distance. So, with the phone in place, we'll be able to see the text, "Hello World." Looks nice and crisp. And as we zoom in, it should stay nice and crisp, even as we focus on the letter A. Now, the image itself won't be quite as high resolution as what's on my phone, but as we can see, even focused on the A, it is still readable.
This video is going to demonstrate the Bluetooth connectivity between the phone, the HC05 module, and the serial communication as output to the HuddyBuddy screen. Now, due to COVID-19 at the stay-at-home order, we do not have the HC05 connected directly to the screen. However, the way the screen handles information is simply reading from serial. And as this is an Arduino-based HC05 and the screen is Arduino-based, development and sending information between the two is very easy. To show what will be sent, I have a serial monitor here to read information that comes in, and I am going to demonstrate that the phone and the app successfully sends data to the module and is able to be read via serial. So to start off, I'm going to boot up the app. So here we have the app. It's fully functional. You can do, zoom in, zoom out, do whatever you want. So the location I am currently recording this video is right here, Stonefield Drive 3939, and I am going to show directions, and it's going to give me lists of directions from this point to the destination. So this is going to be the destination. The HuddyBuddy gets a route via your current location, so the only thing you have to actually set is your destination. And I just wanted to show where exactly I'm located in respect to that. So now I'm going to hit start, And on the left, this blinking light is going to slow down. Yep. And now it's blinking slowly to show a connection has been started. So because I am staying at home to follow the stay at home order, I'm going to emulate the steps that would happen whenever your current location and a steps location is met, meaning that the distance between where you are and the next step is 0. And I will show what will be pushed via serial every time that happens. To emulate this, I have a button that will show what happens every time a distance is reached. So first, so this is the first thing that is said. So in 0.5 miles, stay on Stonefield Drive for 0.5 miles and then take a left. And then after, take a right, 0.3 miles, Ashington Glen Drive. And then here it says 0.3 miles beyond Tanner Road and then take a left. And then again, stay on McCullough for 1.1 miles and then take a left. And this is all the information that will be sent to the screen itself. It will handle information such as a number, as knowing the distance that is left. The distance number in real time would be subtracted based off of you driving. It will take your current location and subtract it from the leg length. And then where it says left and right and whatnot, the screen will be able to handle that and show the correct image of a left arrow, a right arrow, a straight arrow, etc. And that is the functionality between the HuddyBuddy app, the Bluetooth, and reading off of serial.
So this is our custom PCB that we got from JLC PCB, and with the help of Quality Manufacturing Services, they were able to put on the bigger parts such as the Atmega, the SIM, ADXL, and some of like the LEDs and stuff that are really small and hard to put on. They helped us do that. So just kind of going over what's on the board. So up here are the power pins and data pins that come from the that go to the OBD2. Down here are the battery pins for the backup power supply. These 4 pins here are for the OLED, and then these 2 were supposed to be for the photodiode that was going to be used as a dimmer. These holes here would be for when we were supposed to slot in the HC05 Bluetooth module. And then these guys over here are the SPI pins that we use to connect to the Arduino Uno, which we use as a bootloader to push code onto the Atmega 2560. And then on the back here is the SIM card holder for the Ting SIM, and also the SMA connectors for the GSM antenna and the GPS antenna.